Hi, good morning, everyone. Welcome to Tech Dhaba. So today we are going to learn that how whenever you write any code, right? For example, you write in C, how it actually compiles. Okay. So what are the questions we are going to understand today? What does it mean to compile code? What does compiling code look like? And how can code be compiled? Okay. So coding we know, right? We already know how to code, right? We can write the basic code from C. So I'll take that as an example, and then I'll try to make you understand how things works while compilation. Okay, we say that okay, compile the code and run. What happens in background? Okay, so today it is my system, which is Linux system. I'm accessing it from SSH. So this will be like I'm remotely access to a system which is running a Linux. Okay, so we need a Linux system and we need a compiler called GCC. That for that, if you want to read more information, you can go to info space GCC. Right, you will get enough information about that. Right, but I will not suggest you to jump directly to that. We will go one after another. Right. So let's start. So let me start with writing a simple code which is written in a.text. So probably you must have written the code, right? So I'll just write create a file test.c and I'm going to include the standard io.h. Okay, we'll try to understand the code also, why we write these things, why we write main, why we have to write all of these. But the objective currently I'm having is to make you understand how things works on compilation side, right? So, for example, I'll just give you a brief that why we have to include any standard io.h, any header file. Why we do that? Why we do that, guys? Because say, for example, you travel to some other location, right? And you're traveling to US or something, and you're probably going to a country where your language you don't understand the language. What will you do? Nowadays we have a Google Translator, or we are going to carry the dictionary. So dictionary will have all the predefined things already, right? Say, for example, I want to greet in Spanish. I'll say hola, okay? Como estás? Okay. So these are the keywords, right? I'm not aware that what exactly does it mean. Probably I'll convert into my language and try to understand it. So standard io.h is nothing but a header file in which we have all the predefines of the functions like printf, scanf, right? Those are. Okay. Second question I'm having, why we write int main? Okay. Why everything start with int main? It is very basic, guys. So wherever you go, right, you need an entry point. Okay. So where it I has to start. Suppose you go for a run, you need an entry point, right? When we do go for a run, we start from a point A and go to point B. So main is point A. Okay. And then we have a printf, which is a function through which we can print anything on a screen. And we want to return zero. Okay. We'll discuss in detail also why I have to return zero. Just to make you understand now, return zero means success for a program. Okay. So let's compile this code, guys. Okay. So there is a one way, right? I can write a simple command make and then I can write the file name only, not extension. So if I write it, I'm able to see that I got one executable error. Okay. So how to run it? I can just write test. Okay. I can able to print whatever I have written. Now, what happened in background that needs to be understand. Okay. We have to understand what is happening in background. Okay. So we'll discuss it in detail. So if I go to compilation process, okay, it is really important to understand how things compile. So if you're a beginner, you have to understand first when you are writing any code, how your machine is able to understand. Since we know machine only understand what 0 and 1, right? So how you when you write hello world, how it is able to understand it. Okay. So there is a level of abstraction. Okay, this I want to discuss. Your system understand only zeros and ones, right? We are from electronics background, we are from CS background, we are from any background. We know that we when we write any code, it is actually eventually zero and one. Okay, how to prove it? Okay, how to do that? So you know, right? When you write any code, okay, we have to translate into machine code. Why, if it is not, why we have to compile? Okay, so first question is why can't we run directly .c code? Why can't we just can we run this .c code directly? No. So to just convert that language from .c, which is high level language, a human readable language, we have to convert into machine level language. Okay, which is again 0 and 1. In between, we have assembly program. Assembly program is nothing but architectural dependent. So, for example, if I talk about Intel architecture, which generally we use, the laptops and systems are generally Intel architecture. So that assembly will be according to that architecture. Okay, what if I am going to use some other architecture? The assembly code will be different. We are going to prove it. Don't worry. So we understood that, right? So we have a level of abstraction because as a human we write into English like language called C. But my machine will understand 0 and 1. Great. Now next to that, we'll understand what are the stages we have. We have pre-processing, compilation, assembler, and linking. Each of these steps are bifurcated. So when you write a code, you write into .c, .cpp, okay, and then you convert into .exe, okay. .exe you cannot read from human eyes. I'll demonstrate that also, right? So what is the benefit? We have to there are few stages in between which convert your .c into .exe, which is nothing but your binary code, machine code. Okay, so first step is pre-processing. What is pre-processing? When your header file translated to actual code. Okay, so let's see that. Okay, so suppose I want to convert my code into, I want to just do the pre-processing. So there is a command for that. What you write, have to write gcc minus capital E, your file name, and what you have to do? You have to redirect that test.i. I is extension for pre-processing. Okay, so if I do it, let me open the same file which we written. Okay, so how it will look like? Okay, it is got extended. So your library got opened and everything which library had has been came here, right? So why we need it? Because I was using from this library this statement printf, right? So if I will find, I'll try to search printf here. So I could find there are multiple variety of printf. This printf I need, right? Yes. So I need this printf to use it, right? So that is why I have to use that header file. Header file will contain all the data related to that function. Okay, that is pre-processing. I extended everything. Okay, great. What is next step? Compilation. What compilation will do? Will convert my dot pre-processed file into dot s file. S file is assembly file. Okay, let's convert it. Okay, so what I'm gonna do, I have to convert my .i file into .s file, right? So what is that command for that? So let's go into that first. Let me demonstrate that when we process what happened. Okay, so if I, these are the command I have to use for stepping into stages. So first I already used, right? This already used. This is pre-processing. Next step would be my compilation. For compilation, what I'll do, I'll use .i file and I'll mention what file I want to create. Okay. So, okay, if I do ls, I could see I got generated the .s file. Okay. So if I open this .s file, so it is all assembly file, right? Now whole code got converted into assembly. Yes. My main code is there, right? Where I'm printing my hello, right? You could see this string coming, right? So now my code got converted into assembly code. Okay, this is step number 2. Okay, so compilation done, my assembly code got prepared. Now what is next? Assembler. So I generated .s file. Now I have to convert that .s file into .o file, since I have to convert into object file, which is nothing but your binary file. Okay, so let me just convert it. So I'll say, okay, this is .c minus c test.s, and I want to create, okay, if you do that, it is going to generate the object file. Let me show that. So I generated .object file. Okay, now let me, can I open object file? Will you be able to run, read? No, right? Because it become now object file 0 and 1. Okay, so it again, I can't read it. To read it, we have a special tool called objdump minus capital D, and then I will just read it. So I don't have object dump, right? So let me use some other object dump. Sorry, I have written wrong thing. Okay, even that is not installed. So I have to object. Yeah, sorry. Okay, so I had it, but the spelling was incorrect. So I could see now I got the machine codes, right? 0 and 1, right? All the relative values for all this assembly, I generated the you know uh, uh, the machine code, which is 0 and 1, right? So 14 0 0, all these things, right? All sections has been divided, so I can go and check what exactly it is, right? I can go and check, right? Where is my text section, where is my RO data, where is my comment section, right? All these things, where is my notes, why ES frames. We'll go into this deeper, but I just want to make you understand how exactly things are working. So far, how many files we generated? Preprocess file, Okay. So far, what how many files we have generated, guys? We have generated dot c, which we created. After that, we created preprocessed file. We converted after that compiled file. We generated .s file, and after compilation, we do the assembler. Generated .o file, and after generating o file, I need to generate the exe, right? So to generate exe, what shall I write? GCC minus O. This is your flag, your executable name, test underscore exe. Why I'm writing? Because test is already generated as a executable. And then after that, the file name. File name is nothing but the file which you have generated from the assembler. Okay. So now if I ls, I got two executable. One directly when I did the make, and one which I generated is by step process. Okay. So I hope you understood the how many steps are involved, right? So for each steps, we have a specific command. Okay. So if I walk you through again with another example, okay. So here what we are trying to do. Okay. So let me go to that. I hope you understood the exercise which we did. So now I'm going to explain you. Okay. So what is pre-processing? Whenever you do the pre-processing, all things will start from hash. Hash include, hash define, hash if def, all will be converted with the actual value. Okay, today in the particular program which I wrote, I had only one hash, right? There is a possibility you could have multiple hash defines, hash if def, whatnot. All will be converted into actual values. Okay, so that is your pre-processing. Okay, I hope you understand. And the extension will be .i, correct? Now, what will be next? So if I see this example, right, guys, right? In this, what we did, we have a character char underscore min, char underscore max, right? This was the file which I created. When I converted through pre-processing, I could see a lot of, all these header file got converted into actual values, right? What are the function with that header file will be actually expanded. We already seen that, right? In our case. Great. Okay, after processing, what will happen? Compilation. The compilation translate the pre-processed file into assembly code, right? That we already have seen. This change the format and structure of the code, but preserve the semantics. Okay, what it is. Okay, you are going to convert your .c code, which you are already generated, into .i after processing. .s is will be equivalent of your .c file into assembly file. Yes. So if I see it here, what will happen? So this was the code. Okay, when I did the compilation, what happened? All the file converted into assembly code. Okay, that is your compilation process. After compilation, we get into assembler. Assembler will do what? It is going to parse assembly code and going to translate into bits. Okay, there is some flexibility to generate most efficient version of machine code, but mostly responsibility is just to translate the bit. Okay, so we can also optimize that whatever .c file we generated equivalent to .object file which we are creating through assembler, we are going to optimize it, but that is optional. But what is the main goal of assembler? Converting your .s file into .o file. Great. Now what next? We have to do this is how it is going to look. This is your assembly, code into assembly. After translation, you could see this is how it is. A lot of binary code here and there. Yeah, we can see that. And after that, what will happen? After that we need linking. Why we need linking? So linking is needed, right? When you have added standard io.h, right? You only given the declaration of function, but definition of function is not there. So all these definitions need to be added at time of linking. Otherwise, there will be linking errors. Okay. So to do so, we have a linking. So linking will collect all the object and will create, will create what? We're going to create a like this. Okay. I hope you understood so far. Okay. So let's discuss about the GCC, which we started with how to use compiler GCC. Right. So GCC is nothing but a compilation compiler, which is GNU compiler collection. GCC is set of compilers for variety of languages. It provides all the infrastructure for building software in those languages from source code to assembly, right? So GCC will provide you flag and your file name. So there is a format, right? This format I already showed you, right? If I go here, I showed you this. You need to remember always. Okay, what you need to do. Okay, how you're going to convert your file from .c to .object and then eventually .exe. I hope you understood. So let's read about the GCC. Okay. So what are the flags we have? We have multiple flags. Let me open that also. So we have generally -G when you're going to debug the code, -W all, which is like enabling all the warnings, -W error, turn on all the warning into error. Okay. And then if suppose you want to use some specific standard for C, you can also give it. And O, capital O, it is for code optimization. Okay. So how can we check? These are the bare minimum flags we have, right? How can we check the other flags? I can go to GCC minus help. Okay. And there I can get all the flags available, guys. Okay. So I think you understood, right? So there is an idea that you have multiple options available. Okay. Otherwise, these already we discussed these things, right? Compilation and generating it, and there are other flags available. What else you can do is you can go into man page of GCC. It is very detailed. You can go. It is too lengthy. So and you can search whatever your need is, right? So in this we have a good detailed manual is given. Man stands for manual, and GCC we already know, right? So we can go and refer it. Thank you, guys. Thank you for this today. And this was the topic for day. And after that, we are going to start the other topic. Thank you so much for joining. And I hope it was really benefitable for all of you. Thank you so much.